All right, so we're going to talk about factors here. And factors are basically a modification of character strings. And they can be useful in a few different areas. Primarily, we find them useful when we are doing visualization and then also when we do modeling activities. For typical day-to-day data wrangling where we're just doing some summarization, they're not always as important. They can be, but for the most part, I use them pretty heavily when I'm doing visualization and modeling. All right, so factors, they are useful data structure. And like I said, we primarily use them more for modeling and visualizations, but we can use them elsewhere, or we can actually modify them elsewhere and find that useful for typical daily analysis. Working with factors in base R, we can do it. And just like working with strings and date times, it's doable within base R, but it's just there's some syntax inconsistencies, and there's just some things that are just missing that tools that are missing that will make it much easier to work with factors. And so Forcats is a package that is part of the tidyverse that was put together for the purpose of just making managing, dealing, handling, manipulating factors just much easier within R. All right, so to kind of follow along with these slides, what I want you to do is go ahead, load tidyverse, or actually what you could get away with is just loading Forcats in dplyr, or excuse me, ggplot2. We may use dplyr, I can't quite remember, but if you just load tidyverse, you'll have everything that you need. We're also going to use the here package mainly just for setting the path to our data. And then for the data that we're going to use, aside from some simple just basic vector data that we create along the way, we're mainly going to focus on the products and the households data that are actually supplied for this lesson, right? So this is not coming from the complete journey. This is similar data, but it is different, and it's contained in CSV files that you need to import. All right, so let's talk about factors. Well, we know about character strings, and we can see we have here a vector of character strings that just contains blue, green, and green, okay? Now the thing is, let's say that these were certain colors, whether it's eye color or some other thing, right? A factor is basically a character string where there are discrete number of categorical levels that they can be, right? So say that we have our vector where we have blue, green, and green, but the options available, the entirety of options available for the different colors that we could have would be blue, brown, and green. A factor is a way that we can create this categorical data where it still looks like a vector. So let's go ahead and we can run this code where we have our eyes. Eyes. And we have what would normally look like a vector up here, but then underneath it, it says levels. And we can see the levels, these are the options. We could have blue, brown, or green, but our vector only contains blue, green, and green, okay? So the way to think about this is if we have any kind of a vector of character strings, but the options are limited and predefined, or we know about them, then we often can set them up as a factor, right? Now, the thing to realize is when we do this, when we create or convert a character string into a factor, underneath the hood within R, what it's doing is it's just treating each level as a numeric representation, right? So we can see here when I do unclass eyes, we see the numbers 1, 3, and 3. And the reason is because if we look at our original vector where we have blue, green, and green, blue is the first option, so it's assigned number 1. And then the other two values in our vector are green and green. And they align to the category number 3, right? So that's all we're doing. We're assigning these categories, and then there's a numeric representation of the category based off its location. And that's how we can kind of keep track of which levels of our factor we have in our vector. Okay? For the most part, you don't need to worry about the numeric representation. Just realize that that is what's happening underneath the hood. All right, so why is this important? Well, lots of times we'll have categorical variables that can either be ordered or they're unordered, but we have a discrete number of items that we want to look at, or maybe we want to collapse things, right? So, for example, within our households data, we have marital status, and the marital status can either be unknown, married, null, or single, right? And if we look at the income range of our households, we have income range, we have 35 to 49K, 50 to 75K, we have under 35K, we have 100 to 150K, and we have null. So we see we have these different levels or values that our columns can take or our vectors can take. So why would we care about changing these levels? Well, let's look at some examples. If we were to plot the marital variable that we saw before, we get a plot that looks like this, where we have a bar for married, we have a null bar, we have a single bar, and we have an unknown. If we do a bar chart for income range, we can see we get the same thing. We have 100 to 150K, there's a bar there. We have 150K, 35 to 49, and so on. So you may look at this and realize, well, there's some things that we could do that would make this much easier to just read and interpret these plots. For example, with the marital status, we have this null and unknown, right? They're probably the same thing. Like the null is a missing value, means we don't know what the value is. So maybe we'd want to collapse null and the unknown into one category. If we look at the income plot, we see that we have these income ranges that naturally, when we think about them, they're ordered, but the plot is not ordered, right? The actual values in this column are not of any kind of ordered levels, right? So it'd be kind of nice to be able to order those. This is the kind of stuff that factors are useful for. So some of the most useful skills that we do with factors: reordering the levels, recoding levels, and then collapsing levels. And the forcats package has functions similar to the string R package, where everything starts with str underscore. With forcats, everything starts with fct, so factor, underscore, and then the function, such as relevel, recode, collapse, unique. All right, so let's look at the income range. And before, we saw this plot right here on the right where the income ranges, the bar chart was not ordered in any way. Well, what we could do is we could actually create this, or turn this income range into a factor. But when we do it, we could re-level it, right? So here what we're doing is we're taking households, we're going to go ahead and mutate, create a new column, income range, which is just going to recode the existing column is what we're doing. And we're going to turn income range into a factor, but we're going to re-level it when we do it. And so after I pass the variable that we want to turn into a factor or that we want to re-level, I pass the actual levels in the order of interest. Right? So here I have under 35K, then 35 to 49K, and you could follow this all the way up to 150K and then null. Right, so now we convert this into a factor. Now after we do that, if we were to get the counts or do some analysis on it, right, the output is actually in an ordered fashion. So now we get the total counts in the order that we specified in this factor relevel function up here, right? So this makes sense. We could basically follow the income range in the order that we think about in our head and look at the observations. And this actually trickles over to our plot. So now when we actually plot income range with a bar chart, we see that those bars are ordered in the order that we would think of an income range. Under 35K first, 35 to 49K, then 50 to 74, and so on. Now, one thing you may notice is here we have this category called null, right? So we've re-leveled our factor, but now we have this one level that's null, which basically means it's either missing, we don't know what it is, right? We just don't have the income range for those observations. So what we could do is we could use the factor recode function. So now I'm doing the same thing I did before, where I take income range, which now is a factor, but I want to recode it. So I recode it with factor recode, and I say I want to create a new level or category that's called unknown, and that is going to be basically the existing null level, right? So we are recoding the null level to become unknown. So now what we see is both in our plot and over in this analysis here where we get the counts, we see that null has now turned into unknown. Now we can also collapse certain levels, right? So if we were to go back and take a look at the marital, so let's see, we have households, and let me just get the count of the marital variable, right? We have married, we have null, single, and unknown. So null and unknown is likely representing the same thing. We don't know what the marital status is for those observations. So we may want to collapse them. So I could do that. I could do factor collapse, and I'm going to do that with my marital. So I'm just mutating that existing column and factor. And what I'm going to do is I'm going to set basically the existing levels of null and unknown. I'm going to turn those into one level called unknown, right? So this is basically we're collapsing null and unknown into one value that we're calling known. Right now, this again I follow with relevel, and here's kind of a pretty cool tip is if I, like in this case, I wanted to re-level my factor and so that the unknown level shows up at the end. So what I could do is I could just say, I want to re-level my marital factor, and I want to take the unknown level and I want to put it after, and I just put inf, which just means throw it at the very end. Right? So now when I plot my marital status, now I get married, single, and unknown. All right, sometimes we just want to reorder a factor for plotting purposes. So lots of times we have an existing factor or a character, and it's like we don't want to change the raw data source, but what we want to do is to go ahead and when we do a plot, we want to manipulate the levels for plotting purposes. And we can do that. We can do that easily with these three main functions: factor in frequency, factor reverse, which is the reverse order, and then factor reorder. All right, what do these look like? Well, if I wanted to go ahead and create a bar plot of home ownership, I could plot it from based off of the frequency, right? So if I pass, let's see, all right, how can I translate this? Households, what we're doing is we've taken the homeowner, we've collapsed it here because we had unknown and null home ownership. We collapsed that into known. And then I want to go ahead and plot this. And I want to plot the homeowner variable and just do a bar plot. But I want to have the bars ordered in the frequency. So if I just wrap homeowner with this factor in frequency, it is going to now order the bars based off of the most frequent to the least frequent. Now you could reverse that, right? We could use factor reverse in order to basically do the same thing, but now we want to plot it from the most infrequent observations to the most frequent. And then probably the one that I use the most is where we have, let's say, two columns, one where we have some factor, or in this case, a character string, right? Some discrete levels, and I've got some summary statistic aligned to each level. Now, when I plot this, right, so if I were to go ahead and take this and plot this, let me go ahead and just show you what the default would look like. ggplot, and I want to do commodity and n on the y-axis, and I'm going to do geom call. Whoops, let's see. I want geom point, and I actually need to flip these two. And there we go. Let's see. All right. So by default, when I try to create the same kind of plot that you see in the slide, but without doing any kind of reordering, we get this that you see in my RStudio, right? And this is really tough. So if you were to take this to a decision maker, he would say, well, what am I trying to figure out here? Like, where's that item or commodity that's got the most observations versus those that have the least? And it's tough for them to draw insights from. It's tough for us to draw insights from. It's flat out an ugly plot. So how can we fix this? Well, I could actually reorder the plot. So here, where I have my commodity on the x-axis, I actually want to reorder. So I'm saying with this factor reorder the commodity based off of the values in the n column. And then when I do that, I now get this. Let me go ahead and I can do this on my RStudio and make it larger so we can compare and contrast. Now, what I get is a plot that has a nicely ordered from most to least observations for the commodities. This is much easier to understand. I can tell right away, all right, my top 5 items that have the most frequent or most number of observations: grocery staple, gift, household, clothing, and personal care. The 2 with the least amount of observations are meat and poultry within the meat department, or turkey and poultry within the meat department. All right, so factor reorder is super helpful, and I use it all the time when doing plots like this. All right, so I want you to go ahead, pause the video, work through this challenge. You're going to use the households data. And what I want you to do is recode the HH size, the household size factor, so that the null is now unknown. I want you to relevel the household size variable so that unknown is at the end. And then I want you to use a bar chart to illustrate the distribution of the household size in our data. All right, so I hope you got through that. And we can do this pretty much all in one sequence of code. So here, I'm going to do number 1 and number 2 within a mutate statement. So I'm going to mutate the household size variable. I'm going to recode so that the null values or level is now called unknown. So number 2 says relevel the household size factor so that unknown is at the end. Well, I can use factor relevel to do so. And I take household size and I take the unknown and I'm going to place that after equals inf. That means put it at the very end. And then the last one says use a bar chart to illustrate the distribution of household size in our data. And so now I go ahead and just pipe that right into ggplot and I use geombar to get my bar chart. Right. So now I can look at my household size in their order of smallest to largest households and then throw unknown at the end. All right, key things to remember. The primary factor functions that we often use are factor relevel to reorder or relevel in which I can place the order of factor levels. Factor recode to recode factor levels. Factor collapse to collapse levels into less number of levels. I can do factor reorder, especially when I'm plotting, and that allows me to reorder factor levels based on another column. And then you saw factor in frequency and also factor reverse to change the ordering of the factors based off of the frequency. And there's several other type of factor functions, all having the same pattern here that can do many other things. So we're just touching on the basics of forcats. but these honestly are the ones that I would probably use 99% of the time. But there's many other functionalities you may find useful. All right, there's also a cheat sheet that you can use. You may find this helpful as you're doing some programming. And that's it. So I would say if you got questions, obviously the first thing you want to do is make sure you get through the reading lesson. That will go into a little bit more detail and provide more code examples for you to work with. And then if you have additional questions after that, hit up the discussion board on Canvas.